Hello everyone and welcome to day 14 of the 2024 Advent of Code. We're going to be using Python to solve this one and let's jump straight into it. So today's puzzle, we've got a bunch of positions and velocities that look like this, and each of these points is going to move in this velocity once per second on a grid that looks like this, and the grid is infinitely wrapping. So you can see in this case where we're moving right by 2 and up by 3, it's going to wrap back around the bottom, and then when it hits the side it's going to wrap back around from the right to the left. And what we have to do is simulate this for 100 seconds, and we should get something like this. And then we chop it into quarters by removing the middle column in the middle row. We get these values, so there's 1 in this one, 3 in this one, 4 in this one, 1 in this one, and then times those 4 numbers together. And that's what we should do. And then part 2, there's a little Easter egg there. So let's jump straight into this. We've just got the example data here that we just copied over. And if I just print that, that's exactly what we see here. Now we'll save the robot info to a list, and we'll make it like a 4-part tuple. I'm not sure if that's the right way to describe it, but you know, it's kind of like something like that, with the position to start with and then the velocity. So for each of these there's a pattern, and it always follows the same pattern, so we can just use some simple regex, and it's always going to look like this. So if I copy this here, it's always going to look like this. And so to get the regex that we need, we just need to escape the special characters, and then we can add a capture group around what we want. So we want these 4 numbers, and then I'll get on to the minus sign in just a second. I'll leave it there just for reference. And then instead of a single number like this, because this would only capture the first one, we want to look for digits, and in fact we want to look for any number of digits. So it could be 4, could be 55, 155, and this will get all of the positive ones. So say this one, and this one if it didn't have a minus sign. And the way that we want to say maybe has a minus sign is like this. So this says this character may or may not be there, just like that. It's an optional, and that should be it. And then what we want to do is say to match on this. So we're going to import this in a second. We're going to match on this pattern to our line, and this is for import regex. And then we say if match, which should happen every time. We're going to get all 4. So when you go like pattern, when you go match 0, that's the whole thing. That's the whole thing. No capture groups. Then that's this capture group, that capture group, and so on. So we're going to have all these capture groups, but then we're going to wrap them in an int, because we want to deal with integers and not like strings that look like integers like that. And then we're just going to append like that. So we're just going to be adding a bunch of them. So let's do a bit of a sanity check and just check that out. And you can see here for the first one, which was 0, 4, 3, minus 3, we've got 0, 4, 3, minus 3. Great. And then there's a few things that we need to hard code. So it tells us that we have to do 100 iterations. And it also tells us that there's a width and a height. Width, which in this case is 11, and height is 7. And it tells us that in the example, but also it tells us that it tells us what it should be for the input for the actual data. So we'll switch this to what the actual data is when we switch over from the example data. And so then what we want to say is, we want to say for instruction for robot, in the robot info, we're going to apply the velocity to it. But what we could do is we could apply the velocity 100 times. So like once and then put it back in the grid, because if you go over the side, so say here, if you go over the side, you know, it wraps back around. So we could apply, then check to see if it's in the grid, put it in the grid, and then keep going like that. Or what you can do with modular arithmetic, which is what this is, we can actually just do all the times in together and then do one singular modulo. So rather than doing 100 iterations per piece of info that we have here, we can just do one simple calculation, which is really nice. So I'm just going to deconstruct what we had here into the different parts. So we've got x and y for the position, then we've got dx dy for the change in position, and the final position, the x value at least, is going to be this x variable plus dx n many times, and the same here for the y value. However, this is now going to be, you know, really big or great in magnitude, either like really positive or very, very negative. And all we then need to do is just use modular arithmetic. So we can just use the modular symbol like this. And for the x value, it'll be the width. And then for the y value, it'll be the height. And that'll give us the final position there. And what we want to do is do that for every single one and keep a list of those. So I could say final positions is another list, and I'm going to take this, append, and add the x and y. Remember that we don't need to store any other information other than the x and y, because we're just interested in where they end up after 100. And then, so now we've got, if we just check our final positions, this should be a plural. We've got a bunch here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we can see here there's 12 initial states. So that looks plausible. I'm going to stop printing that out. And then what it says is chop out the middle column and chop out the middle row, and then split them into groups like this. So first of all, it'd be easy if we found the middle column. And the way we're going to do that is the width divided by 2, and the middle row is going to be the height divided by 2. And what we're then going to do is we're going to do 4 lists where we're going to use strictly greater than or less than these things. So the elements that are equal to these for their x and y value are not going to be counted. And I'll show you here. So we've got top left, for example. That's going to be positions, say P for P in final positions. If this position has its x value less than the middle column and its y value is less than the middle row. So that's because we're counting, we count P going positive, so we count the y variable going positively down like that. So this is 0, 0, 0, 1, and so on. So that's going to be the top left. And then similarly, the other 3 will just be flipping things around. So I'll just do them quickly now. There we go. And now we've got the 4 different parts. And the answer says to just multiply all these together. So multiply the amount that are in each of these. So the length of the top left multiplied by top right, bottom left, bottom right, and if that's the answer, print the answer. And we should get 12 for this setup, which we have here. And then it says with the data that it gives us, with 101 wide and 103 tall, what does it look like then? So if I go to 101, 103, and I switch to the input data, we get this number ending in 332, which is exactly what we get here. Okay, then moving on to part 2, we say here that when we keep iterating over and over, when we do, say this is one iteration, this is a second, this is a third, for all of the points, at some point, they will make an Easter egg, and the Easter egg is going to look like a Christmas tree. And there are multiple different ways to do this. I've seen people do it with some sort of statistical analysis, some like looking at the spread of the X and Y values. What I'm going to do is I'm going to say this picture probably contains a block like this, a 3x3 block. And after every iteration, I'm just going to check for that 3x3 block. So let's give that a go. So I'm going to say while true, which should, raise some eyebrows, but I will do a break in this. So I'm going to have a counter n, and I'm going to increase my counter. And what I'm going to do is, right now I won't, but I'll say final position. I was going to print here, but I'll show you afterwards why I wanted to do that. I've got my final positions, and I'm going to go through for robot in robot info. Just like I did here, I'm going to take this and each time, instead of doing all n at the same time, I'm just going to do 1. So I'm going to remove a few of these brackets. So we're just going to do 1 and then make sure it's back in the map, and then append. And then what we will do is we'll say if, and I'm going to make a new function in a second called contains block, which is that 3x3 that we just talked about. That's going to be those positions. If so, then pretty print, which we're also going to make, which is just going to print out to the console. Then print n equals n, so we know which iteration it's on, and break, which should ease the tension here, why there's a while true and a break, and you just have to believe me that this will hit. Okay, and then if we don't get to this, so we apply all this and we check. If it's not true, then we need to somehow change the robot information, because every time we'd just be doing the same calculation over and over, the same input coming in. And so for that, what we're going to do is we're going to add a new robot info, or next robot info. And whenever we append here, we're also going to append here whilst keeping a track of the velocity onto the new robot info. And if it doesn't contain the block, then I'm just going to make the robot info the new robot info. So it's going to go through once, calculate all of these. If it contains this block, break, and we're done. If not, then what we've just calculated we'll put back into it, and it'll just go over and over and over. Okay, great. And then we just have 2 functions to make. So the first one is going to be contains block, and that's going to be on a set of positions, or a list of positions, or an array of positions, I should say. And all that's going to do is it's going to, for j in the map height, so map height, and for I in the width, which is a common pattern you see. I'm just going to go over every point in the grid, so in the 101 by 103 grid. and I'm going to define something called surrounding points, which is just going to be the 3x3 grid of points with ij in the middle. And I'll just do that quickly now. Okay, these should be all the surrounding points. This will make a 3x3 block, and we're just going to see if this 3x3 block is in the positions. And there are a few different ways that you can do this, but the way that I've chosen to do it is to turn this into a set here. So position set is equal to the set of this, and then doing a check to see if it's in the set is much quicker. It's each individual one, because it's a hash set, it can do like very quickly, just says calculate the hash and then look it up, rather than having to look through. If this was a list, it would have to check every one of them. And I can just do if all points, or if all point in the position set, if all point in the position set for point in the surrounding points. And this will be true if all of these 9 points are in this position set. And if that is true, I'm going to return true. And if not, by the time all the combinations of i's and j's have been, false. And I'm sure there are faster ways or more efficient ways to do this check, but this worked fine. It had a little bit of a wait time at the end, but it was absolutely fine. And then the last thing that we want to run is this pretty print, which is just going to print it all to the console. And similarly to how I just did then with the double range like this, I'm going to print the I and j position. So if I and j in is in it in this set of positions, I'm going to print something, and if it's not in it, I'll print something else. So you'll get the two icons. So if ij is in final positions, and actually I could make this a set if I wanted it to be faster, but it's fast enough. I'm going to do something, and then else I'm going to do something else. And if it is there, I'm going to print an x, and if it's not there, I'm going to print a dot. But this would print a new line every time, and just to get rid of that, you can use this. And then after each set of I, so after we've done all of one row, I'm going to just print empty like that. So it'll go all the way across a row, and then it'll print a new line character and start going again. And that should give us our answer. So if I don't think it gives an example. No, so if we jump straight in with the data, so that's correct. It will just take a few seconds to run, so I'll run it and then I'll pause. In fact, I'm going to, this is what I said I was going to do later. I'm going to print n here. I know when n, what n this pops up at, but just to see something on the terminal, rather than seeing nothing and it potentially be frozen. You might want to do this every 100 or every 1000. I'm just going to print every n for now. Okay, so I'll run this now. There we go, it's run to 7,790, and here is the Easter egg there. And there we go. So there are loads of different ways that you could do this. I saw some people just printing this to a file and then using the file explorer to kind of see when this pops up, but we're just checking for any 3x3 grid here, and that was good enough. And I kind of took a punt that there would be no other clustering of that. If you wanted to be a bit surer, you could do a sort of 5x5 or a larger grid, but it obviously would take more per check. But that's it. And then the number we needed was 7,790, which is exactly what we had for part 2. So a little bit of an easier one for this, where part 1 I felt was relatively straightforward, but part 2 was tricky. You had to make a bit of an assumption on what the tree would look like, or see on the Reddit, or do something like that. Lots of different creative ways to do it. So please let me know in the comments how you solved part 2. I did see some really interesting ways, so I'll be interested to hear about yours. If you did like, please remember to leave a like, and I'll be doing a video for each of the day's puzzles, and I'll see you for day 15.